Hello friends, welcome to my YouTube channel Physicscafe by Manjeet Kaur. In this video we study about motion. Before we discuss about graphical representation of position time graph, velocity time graph and acceleration time graph, we know some basic about graph. In graph we have two axes. One is horizontal axis which is x-axis and another is vertical axis which is y-axis. So always remember the independent variable belongs to x-axis and the dependent variable belongs to y variable. So in this chapter we have four variables: time, position, velocity and acceleration. So we take independent variable as time and position, velocity and acceleration taken as dependent variables. Now we have position time graph. Position means object's displacement, how much it moves from its origin. XT graph at rest, that means position graph at rest. Rest means the object is not changing its position with respect to surrounding, that means the object not change its position, it stays at rest. In this graph, x denotes to position, here we have position time graph. Position means object's displacement, how much object changes its position. XT graph at rest. Rest means the object is not changing its position with respect to surrounding. That means object not changing its position, it stays at rest. In this graph, x is constant, but because object is at rest, but time varies, so position time graph is parallel to x-axis. In this graph, position is taken along y-axis because it is dependent variable, and time is taken along x-axis which is independent variable. So that is origin, that is point A. The object is placed at point A, this 2 meter distance from origin. So at time 0 second the object placed at this point. After time 1 second the object is placed at 2 meter that point. Time increases but object doesn't move its position, so position time graph is parallel to x-axis. Now we have XT graph at uniform motion. In uniform motion the velocity of the object is constant, so that slope of the graph is constant. We know what is uniform motion. In part number 3, I already discussed about what is uniform motion. In uniform motion, the object covers equal distance in equal intervals of time, so that the slope of the graph is also constant. In this graph, that is time, that is position which is along y-axis. In this graph, that is point A's coordinate, and that is point O, that is 1 meter distance, that is 2 meter distance. Similarly 1 second, 2 second. So coordinates of A are, that is A and that is B. So coordinates of A are 1 second and 1 meter. Similarly coordinates of B are 2 second and 2 meter. So by using this coordinate we find the velocity of the object. We know the formula of velocity equals to, now we have the example. If an object has initial speed is 10 meter in 5 seconds and final speed is 20 meter in time 10 seconds, find its velocity. So we have, that is object's movement displacement, how much it moves, that is time taken by object. So displacement equals to s2 minus s1 and time equals to t2 minus t1. So velocity formula is d upon t, which is equals to s2 minus s1 upon t2 minus t1. So put these values in this formula. V equals to final speed 20 minus initial speed 10 upon final time 10 minus initial time 5. So B equals to 10 upon 5 meter per second. So velocity we get 2 meter per second. That means the object cover 2 meter per second in equal intervals of time. In position time graph at uniform motion, In this, velocity of the object is varies with respect to time. We know in non-uniform motion the body covers unequal distance in equal intervals of time, so that the velocity of the object changes. So thus slope also varies. In this graph we clearly visible the slope of the object is increasing by increasing velocity of the object. So thank you for watching my video. Like my video and subscribe my channel.